Hello, I'm Michael, and I'm here to show off a little C++ library I've been working on in my spare time. It's called hot constants, and it allows you to tweak hard-coded values live while you're debugging your apps. To demonstrate this, I've set up a simple console application here that defines a constant, and then every second in a while loop, it prints it out onto the screen. Let's press F5 to build and run it. And no surprises here. Every second we see the test constant is 5 print out onto the console. Let me go ahead and end that. Now let's say I wanted to change this app to print another number instead. At present, testing other values means stopping, rebuilding, and then restarting the app. And while that's trivial in this example, if this were a larger program, these steps could be very disruptive. So instead, I'm going to change this constant into a hot constant by first including the hot constants header, and then changing the declaration to use the HC macro like this. And we're done. Now, hot constants is a zero refactor solution, so I don't need to change any of my other code. I only need to change the declaration. So now if I press F5 to build and debug the app, you can see that the program behavior is unchanged. However, now that I've added the hot constants macro in the definition or the declaration, it has a special property. Let me make this split view so you can see both sides at once. Now that this is a hot constant, all I need to do to test out a new value is change it in the source code. So if I replace this 5 with a 6, then I hit Control S to save the file, you'll see that the application on the right says that it's reloaded the file, and it's immediately reflecting test constant is 6, even though I haven't changed any of my code in here. Well, this is obviously a really contrived example. What I just demonstrated is actually a really powerful tool. With minimal setup, I've added the ability for this constant to reload from the source code on the fly. And in case you were wondering, yes, this is still a constant. If you take a look at the preprocessor output on the release build, the HC macro simply expands into a regular constant, which means that it's still subject to compiler optimizations. In some scenarios, this can be a huge time saver. For example, let's say you're making a platforming game from scratch. The foundation of any platformer is the player's ability to jump. If jumping isn't fun, then your platformer is probably off to a bad start. In order to make the jump feel fun, you'll have to spend a lot of time tweaking your game's core values, including the jump height, the hang time, coyote time, and a whole bunch of other values. In game engines like Unity, you're provided ways to tweak these kinds of values live from an inspector. But if you're using a smaller game engine, or no game engine at all, then your values are likely to be hard-coded instead. And that makes tweaking these kinds of values utterly tedious. Hot constants was developed with game development scenarios like this one in mind. Now you can easily tweak your values without even pausing your game, and setup was dead simple. And that's pretty much hot constants in a nutshell. There's just two more things to show off. First, hot constants isn't limited to reloading simple values. The reload mechanism employs a full recursive descent parser, which can evaluate and reload pretty much any valid C++ expression using any literal types. So if you need a constant value that represents a 60th of a second, just set it to 1 over 60. It's also possible to declare an extern hot constant. This allows you to share hot constants across translation units, just like regular extern constants. To declare an extern hot constant, simply use the HCEX macro instead, and skip the assignment. When the constant definition is updated, code that uses the extern reference will see the new value too. Hot constants is available for free on GitHub under the MIT license, so feel free to use it in your own projects. At the moment, it only works for C++ 17 on Mac and Windows, but in the future I expect I'll rewrite the headers so that they can be used in C++ 11 and C++ 20 projects as well. Let me know if you find it useful, and if you have any suggestions on how to improve it, feel free to submit a pull request. But that's all I got for now, so thanks for checking this out, and see you later.